Welcome back to Data to Crunch. If you are new here, this is the part of series, so I would recommend you to start from part 1. Link is in the description box below. If you are continuing from last video, let's get straight into it. Now let's start with our silver layer work. First thing, we need to set our environment. For that, we need to set our database. As we are working on our development environment, we need to set our database as Flowbridge Dev DB. So we can directly say use database and we can assign our database name. Let's say suppose if in case you want to use this SQL file into multiple environments, okay? So for now in Snowflake, we are going to use zero copy cloning. But if in case you would like to use one SQL file to multiple environments, then we need to set this database as a dynamic variable, okay? So I'll show you how we can set this variable as a dynamic variable. Database as a dynamic variable. You can directly hardcode it as use database and database name. I'm showing you another way how to set this database as a variable, okay? Then I think our database name was, yes, Flowbridge Dev DB, okay? So we can say Flowbridge. Not Flowbridge, it should be Dev. And then we will set our database as, here we will say Flowbridge underscore, and then we will use our variable, and again we will say db. Run this. Now we will say use database, and we will use here identifier, okay? Identifier and then $db. Now we will run this. Now you can see it has set Flowbridge Dev DB, okay? Then let's say suppose if you are using this same file into quality environment or production environment, then over there you will just change this set variable for environment, okay? Here instead you will give QA or prod and then you will run this file. So automatically that file will use that respective database which we have, which you are expected to use for that particular environment. Now let's start with our setting up of role. We'll say use role. We will use sysadmin role. Then we will say use schema. Now our schema would be silver schema. And then warehouse, use warehouse. For this transformation, we will use pipeline warehouse. We will run this. Okay, so now all the our environment has been set and all the parameters of role, warehouse, database, and schema has been set. Now the next role is to create our dead letter. Okay, so we will create transient table for this dead letter table where we will store our bad data. So to create this table, we will say create or replace transient table. We will create this under silver schema and our table name would be dead letter. And now we will declare our column names. First again column would be raw data of variant type. Then we will also have one column as error reason where we will mention the reason for which we have scrapped that data. Then we will mention file name of that entry, file row number, and then we will declare we will have one column as rejected at of type timestamp mtz, and its default value would be current timestamp. And again, in the comment section, we will mention one comment about this table. We'll say dead letter table, rejected or bad records from bronze. We will run this. Now, under databases, we will cross verify. Now it is under silver layer. We can see tables object, and this is our table. You can also cross verify from Snowsite too. Now our next step is to create our another table. That one is STG orders. Okay. So whatever we are left with from this scrap data, that entries will go under this STG orders. And along with inserting those entries into STG orders, we will perform some data cleaning part too. Okay. And that table would be our standard table or permanent table, and we will perform flattening of that data, and we will clean that JSON files. Okay. Now let's start with our creation of standard table. For this, we need to just say create or replace table. So by default, this table would be standard or permanent table under silver schema, and our table name would be STG orders. Now we need to mention our all column names here. And our column names under table STG orders would be these ones. So for order fields, we have column as order ID, order date, and order status. For customers field, we have customer ID, name, region, and segment. For supplier field, we have supplier ID, name, supplier country, lead time dates, and performance score. For shipment fields, we have shipment ID, carrier, ship date, estimated delivery, and delay days. For products field, we have product ID, name, category, quantity, and unit price. We have two financial fields, those are total amount and payment status. Warehouse fields, we have warehouse ID, location, and inventory level. And we will mention some metadata too, and that will be file name, file row number, ingested at, and transformed at. And this would be our silver layer stage 1 table where we will flatten our data. Okay. Now quickly run this. Our table has been created successfully. STG orders. From Snowsite 2, we can check it. Just refresh your Horizon catalog. And this is under our silver schema, tables, and this is STG orders table. It will mention table details too, along with table definition, their privileges. All the columns will be listed out here. We have 31 columns here. Data preview. As of now, we have no data into this. Copy history, nothing, because we haven't copied our data from bronze layer to silver layer yet. And this is data quality. Now moving back to our SQL file. Our next step would be to create stream. Okay. So this stream will capture only new records which we will get from bronze layer. Okay. To create this stream, we'll say create or replace stream. We will create this stream under silver schema, and our stream name would be raw orders stream. Now we need to mention on which table we would like to have. So on table and table name. So we will mention our naming convention. Our table name would be from dev database, from bronze schema, and then our table name would be raw orders. And we will say append only as true. We are going to use, or we are going to just append our values. Okay. Then show initial rows, we will set it as true. Then we will mention one comment. We'll say stream on raw orders captures new data for silver processing. Now quickly run this. So let's say suppose if you'd like to check all the streams, then you can simply say show streams and run. It will show you stream which we created just now under silver schema. Okay. Now we are done with stream. Our next part is to create stored procedure. Okay. And then once we create that stored procedure, we will use that under task. Now when we create our stored procedure name would be this one, SP bronze to silver. We have two main purposes to create this SP. First, to route bad records to dead letter, and then to merge clean records into STG orders. Okay. So for this, we have created these two tables, and we have also created stream, which we will use to create this stored procedure. And why we are referring this stored procedure or using this SP here? Because SPs are reusable. We can test those SPs independently, and it is a clean separation from task orchestration logic. Okay. Otherwise, if you'll write all this logic under task, that would be very difficult to understand. So for the better understanding, we are individually writing that data cleaning part under stored procedure. Okay. Let's quickly create our SP. Now we will say create or replace procedure, and our procedure would come under silver schema, and our procedure name would be SP bronze to silver, and this SP will return string. So we need to mention returns string. Then we need to mention language. So here our language would be SQL. If needed, you can mention comment. We'll say SP routes bad records to dead letter and merges clean records to will be called by. Now we need to mention as, and complete logic will come in this section. Okay. So we need to say begin. Now first logic is to create our buffer stream into temporary table, is to buffer our stream, not create, buffer our stream into temporary table, because stream can only be consumed once per DML statement, and we need to materialize it here. Okay. So both our dead letter and merge will happen, and we can read from the same snapshot. So to create temporary table, first step in our this data cleaning part, we will start with begin and we will end it with end, and within this begin and end we will write our logic. Okay. Now first step is to create our temporary table. Let's start writing our code. Create or replace. Now to create temporary table, we need to mention keyword temporary and then table. Our table name would be stream buffer, and we'll say as select star from, and we are going to utilize here our stream where we have gotten our new append only data. So that stream we will read into our temporary table. We can mention one where statement where metadata action is insert. Any which ways this is append only. So part 0 is done. Now next part comes where we will route our bad records to dead letter. Okay. So these To write this logic, we will use insert into statement. So our logic would be this one. I'll explain you step by step. So we are saying insert into, and then we are mentioning our dead letter table name. And here, if you remember, we have 4 columns, raw data, then we need to mention error reason, file name, and file row number. So we are selecting our data from this temporary table which we created on stream, right? From there, we are selecting our data and we are performing and validating our data from there. So for that, we are saying select star from, and then we are mentioning one alias as S. Now, for these 4 columns, we are mentioning S dot raw data for this column raw data. Then we need to mention error reason. And to mention error reason, we need to cross verify some of the entries. So to write that logic, we are mentioning this case statement. Okay, so this case will start here. We will write our logic in that, and then we will end our case as end as, and then we will mention our column name. So this all logic will be written for this error reason. Then we need to mention our file name and file row number. So to mention that, if you come down after ending the case, we need to mention s dot file name and s dot row number from our temporary table. And then we need to mention our where logic also. But before that, let's try to understand what we have written with these case statements. So with these case statements, we are checking first we will have our order level validation. Okay, so let me open Notepad. Okay, so this is how our data looks like. Okay, now first is to check order ID, this order ID. Okay, we need to check if it is null or not. So to flatten our data, or to check or to extract this order ID from our JSON file, we need to mention, right now our data is into this column as raw data. Okay, so we need to mention s dot raw data, then one colon, and from there we need to pull order ID, which is this one. And then with 2 columns, we need to mention data type of that column. So our data type for that column would be string. So we are checking if order ID is null, then we will mention reason as missing order ID. Then we are checking order date. Again, we are extracting order date in the same way. We are flattening it in the same way. And we are checking if it is null, and if that particular date type is not as expected, then we are mentioning that reason as invalid or missing order date. So this would be this one, order date. Then we are checking it for order status. For that, first we are trimming it. We are trimming initial or leading or lagging zeros, and then we are converting it into uppercase. And we are checking if our order status is not from any one of these values, pending, processing, shipped, in transit, delivered, or cancelled, then we need to mention reason as invalid order status. And along with that, we will mention what order status we have gotten. Okay, so for that purpose, we will use this coalesce function. And with coalesce function, we will mention that respective order status which we have gotten along with this invalid order status. Now we need to perform one customer level validation. So we will check customer ID. So if you see how we are extracting this, s dot, this complete is our raw data. So from raw data we are extracting customer dot customer ID, and we are mentioning customer ID data type with double colon string. Okay, is null, then we will mention missing customer ID. Then we are checking it for supplier level. For supplier level, we are checking if supplier ID is null, then we will say missing supplier ID. Then along with supplier ID, we are checking it for performance score too. Okay, so the performance score would vary from 0 to 100. So if performance score is greater than 100 or less than 0, then we will say invalid performance score, which is greater than 100, and then we will mention that performance score value. So let's say suppose our performance score here, it came as 200. Okay, so our column entry would be invalid performance score, which is greater than 100, and that is mentioned as 200. Okay, so this is how we will get our error reason. Similarly, we will get the same reason if our performance score value is less than 0. In the same way, we are also checking it for lead time days. Okay, so lead time days would be either from 0 to positive value, any positive value. Any negative value for lead time days would be incorrect. So for that, we are checking if lead time days value is less than 0, then we will mention reason as invalid lead time days. And then we will mention whatever lead time days which we have gotten for that respective entry. Once we are done with this performance level, then we will check for product level. If we come here, product level, if we'll check, we have product values under items. So this is how we are getting values for items. So we need to check s.raw data and these items and 0th value, because this has came as an array. So this is how we read our data if it is into array while reading this JSON file. So it would be s.raw data colon items 0 dot product ID, and then we need to mention data type. If it is null, then we will mention it as missing product ID. Then we will check for quantity. If it is null or less than 0, this can't be, this is not a possible scenario. Okay, so we will check that value with OR statement. If this value is null or greater than, if less than or equal to 0, then we will mention invalid quantity, and along with that we will mention what quantity number we have gotten in this product level. Then similarly we will check for unit price. If it is null or less than 0, then we will say invalid unit price. Then for financial level, we have two values, which is total amount. Sorry, one value which is, yes, payment. We have two values, payment status and total amount. So we will check total amount. If it is null or less than 0, then we will say invalid total amount. And similarly, we will check for warehouse level. If warehouse level is less than 0, then we will mention invalid inventory level. Else we will give that reason as unknown. Okay, then we are ending our case from temporary table which we have created, and then we need to mention where condition. So these where conditions would be all, we will mention all the column names which we have used under this case statement. Okay, so all these column names we will utilize under where statement. Hence we will say where this order ID is null, or this order date is null, or this statement is not in not in these list. Then customer level null, supplier ID null. Similarly, we will check it for rest of the columns. So this is how we will write our logic to route our data from the stream to dead letter. Now let's write our merge part. So we will merge our clean records into STG orders. Technically speaking, we will use SCD type 1 merge here. So if in case we have entry already present into table, that means that we need to perform update. And if we don't have that entry present in our table, that means that that entry is new and we need to insert that as a new order. So our merge statement would look like this. I'll explain you step by step. So merged into, and then we will mention our target table, which is nothing but STG orders, which we will use henceforth in our project using select, and we are using select particular columns from our temporary table, which is nothing but this stream buffer table, and we are using alias here as S. So first check what we have written here in this. So first we are checking it for order fields. Okay, We will extract and we will normalize our core or order identifiers. So first we will focus on order ID. We are uppercasing our order ID for the consistency purpose. Okay, so first we will trim it and then we will use uppercase to uppercase our order ID. Then we are using this logic for order date. So our order ID is gonna look like this, ORD and then order number. Okay. Then we are using case statement for order date. We are checking order date format. If that format is DDMMYYYY, then we are converting that format into ISO format, and this would be our ISO format. If we are already getting order date as ISO format, then we are doing nothing. So that statement will go, or that logic will go under this else statement. So for this order date, we are using try to timestamp NTZ for safe parsing, because if we get any null value as a bad record, then instead of failing this query, we will safe parse it. Okay, so for that purpose, we are using try to timestamp NTZ. Case statement which will end here, and under this we will write when statement with our logic. Then we are uppercasing our order status to standardize it. Okay, so we have performed or clean data for order ID, order date, and order status for these order fields. Now let's move on to our customer fields. Again, for the customer fields, this would be customer ID is going to be our foreign key to customer dimension when we create our star schema. So for that, we are for to standardize it, we are uppercasing our customer ID. Okay, then customer name, customer region, and customer segment, we are defaulting it to unknown. So if in case we get null values for these three columns, we will change those null values as a unknown. Okay. For that sake, we will use coalesce statement, coalesce function here, and then we will change it to unknown. Afterwards, we will make some changes for supplier field. Again, supplier ID is going to be our foreign key for supplier dimension. So we are uppercasing it to for just to standardize it. Then we are using coalesce function. Then this coalesce function will again default these two null values to unknown. And then these two values, if we get null values, then we are changing it to 0. Okay. And that we will perform for lead time days and performance score. So this is how we will clean our supplier field. So that would be supplier ID, supplier name, supplier country, lead time days, and performance score. Now we will flatten our nested JSON for shipment objects. First, we will default our missing IDs or null IDs to unknown, null shipment IDs to unknown. Similarly, we will default our missing carriers as unknown. Then we will make ship date as null if it is unparsable, and similarly we will make estimated delivery as null if we have any missing or invalid shipment delivery. Then for the delay days, we will floor at 0 so that we will not have any negative delay days. Okay, so for that we will use greatest and then coalesce function. Next, we will flatten our items array, which is JSON array. First, for this would be our first line item product. We will use uppercase to standardize it. Then we are using coalesce function for product name and category. So null values for both of them, both of these columns, we will default it to unknown. Then this this quantity and unit price, we will do nothing for this. We will verify it into where statement. We are just flattening this items array. So if you remember, this is how we have array into our files, which is in JSON, and into this items array we have these fields which are related to our product fields. Then for the financial fields, for this total amount we'll do nothing because we are validating it into where statement. Again, this payment status, we are defaulting null values to unknown. For that, we are first streaming it, then upper, and then coalesce function, we are using it. Then we are working on warehouse fields, which are these warehouse ID, warehouse location, and inventory level. So we are defaulting our missing warehouse IDs as unknown. Then similarly, we are defaulting it to unknown for warehouse location. And in inventory level, we are defaulting null values to 0. This one was for warehouse fields. And along with that, we are mentioning metadata, which we are left with, which is file name, file row number, and ingested rate. All this information, we are fetching it from our temporary table stream buffer, which we have created. Now, this one was select, then we can say these columns from temporary table, and then we need to mention where condition. So this where will be nothing but our validation filter. First, we will check order ID. We will reject values if we have any missing order ID. Then this logic is to accept valid ISO date or accept at least valid format, which is DDMMYYY. Then and condition, and then we are checking our statuses and we are verifying if we have statuses from only acceptable list. Then we are rejecting the values if we have missing customer ID or missing supplier ID. Then we will allow null values that will be coalesced to 0. Then we will reject negative lead time. Then we will reject our missing product IDs. We will reject our null quantities. We will reject our 0 or negative quantities. Then we will reject our null prices or negative prices. Then we will reject our total amount, which is null or negative. Then we will allow null values for inventory level because we are coalescing it to 0. And then we will reject our negative inventory. So this is going to be our source. Now, as I have told you, we are performing SCD1, right? For update and insert. So for that logic, we are matching this condition with order ID. If source order ID matches with target or order ID, then we need to update our values, okay, with those respective changed values. So for that, we have this logic where we are checking all the values. And this SCD type 1 update, it will perform overwrite for mutable fields with latest values. So if in case status is changed, then we will overwrite our status, new status with old status. Similarly for carrier, ship date, estimated delivery to warehouse location. And we will mention our transform date as current timestamp. This is for our audit. When this row will get refreshed or changed, then that time we will log it here under transformed at column. Then if our value is not matched or if our entry is not matched, that means it is new entry and then we need to insert that entry. So to avoid mismapping or to map our values or columns correctly, we are stating this insert. Then we are mentioning all our column names here and values, and those values will be these values from our source table. So this is how we will perform insert, and this is how we will perform our update statement based on matching of order ID from source and target. Then once we are done with writing our merged and insert for dead letter table, we will drop our temporary table which we have created because it is no longer needed. And in return, we will give one statement. We will return one statement as SP bronze to silver completed successfully. And we are ending this begin statement. If you remember, this end is for this begin statement, which we started here. So this end is for this begin statement. So we created stored procedure. Then we begin it. Here we have written three major logics. First, we created temporary table, which we have utilized going forward. Then part one, we have inserted invalid entries into dead letter along with their reasons. So that logic we have written here. Then we have part two, which is merge, std type 1 merge for insert and update. And that values we have updated it into stg orders. That logic we have written here. And once we are done with this logic, we are dropping our temporary table and we are ending our stored procedure. Now let's run this. Now our function has been created successfully. If we come back to Snowsite, see here under silver schema, if you check this stream which we created, this is now present here. Along with all the details, it is mentioning what's the mode, status, definition, privileges, and this is the procedure which we have created just now. You will click on this. It will give you all the details about your SP along with procedure definition. Okay. So from here also you have this option, open in workspaces. If you would like to directly check your stored procedure, and if needed, you need to make some changes, then instead of finding that stored procedure into SQL files, you can just open it here, open it from here. That will open a new SQL file into your workspace, and then you can make that change for this stored procedure. So this is one of the easier way to make some changes. Then coming back to our SQL file. Now we are done with our stored procedure. Now we need to create one task, and then in that task we will call this stored procedure. Okay. So here we can say that create or replace task. Then we need to mention our task name, and we will create this task name task under this silver schema. Let's say our task name is bronze to silver task. And then we need to mention which warehouse we are going to use. So for this data cleaning purpose, we have created Flowbridge pipeline WH warehouse. So that warehouse we will utilize. We will schedule it at the interval of 1 minute. So mention it as 1 minute into inverted commas. And then we will write one comment for this as task, which calls SP bronze to silver every minute when raw order stream has data. So there might be the possibility that this stream doesn't have any data, right? So if this stream doesn't have any data, then scheduling it for 1 minute, it will do nothing. Okay, so it will keep consuming our credits. So for that, we can add one more check where we will check if our stream has data or not. So to check that, we will say system, then $sign, then we'll say stream has data. And then here we will mention our stream name. So our stream name is raw orders stream. Raw orders stream. So we can mention it using when statement as, and then here we will call our stored procedure. Our stored procedure name was SP bronze to silver and semicolon. So this is how we create task. Let's say suppose if you avoid to create stored procedure, right? So instead of writing all this logic which we have written just before into stored procedure, that logic you need to mention after this as, and that all logic will come over here. So instead of writing that complex logic in this task, we have created this stored procedure and we are just calling that stored procedure. Okay. And this stored procedure can be reusable and can be testable into another tasks or into another logic also. Now let's run this task. It states non-existent warehouse. Okay, so it was typing mistake. Now our task has been created. If I refresh this, under tasks object, we have this bronze to silver task with all task details, graph, and run history. So we'll not have any run history because we are yet to fetch our data from bronze to silver. Now to fetch that data from bronze to silver, we need to resume this task. Okay. So this is just creation of task. Now we will resume our task. To resume our task, we need to say alter task, then mention your task name and say resume and then run this. So if you need to check all the tasks, we need to say show tasks. It will show you all the tasks under which are present under this silver schema. You can test or you can call stored procedure individually also. So to call that procedure, we need to say call and then mention that SP. Okay. So our SP name is this one. This is how you can call your stored procedure individually. Run this. So it states invalid identifier. For this, what we can do, we will use Cortex code and we will say fix this. And let's see what Cortex code suggests us. So it has identified issue and then it will make changes. It directly makes changes under our file. Now let's verify what change it has done. Okay, so again typing mistake. Instead of file name, I have missed N here. So if I say keep or keep all, if I'll click, then it will replace that incorrect or syntax error with the correct code. It is also checking for another existing codes just to verify if we have any another issues. Now it says that fix is correct. Issue was a typo mistake. Now rerun the full script from the top, starting from create or replace table dead letter. Okay, so that the table gets recreated correct column name. So now we are going to rerun everything. So starting from this transient table, we will create it first. Then this STG orders table, we will create it. Then we will create this stream. Instead of that, you can say run all to. Then we are creating stored procedure. So this is done. Then we need to recreate our task. This is done. Then we will resume our task. Now let's call our stored procedure again. Okay, SP has been completed successfully. Now let's perform some verification. So now let's check if our stream has data or not. For that, we'll say select system $, and then stream has data. And then we need to mention our stream name, which is raw orders stream. Let's run this query. It says that it states true. Okay, that means our stream has some data. Now let's check if we have values into STG orders or dead table. Okay, dead letter. So what we can do, first let's check the count. Okay, select count star as STG orders count from silver schema STG orders. Let's check both the count all together. So union all, and again similarly select count star from, instead of STG orders we will say dead letter. Run this query. If you can see, we have altogether 263 records into STG orders and 37 into dead letters, and altogether we have 300 records. So if we check our VS Code, this expected in Snowflake, that is coming as expected. In raw orders we got 300 records, STG orders we got 263, and dead letter we got 37 records. Okay, that means that so far we are going correct. Now let's verify entries into our table. So for that, simply we will say select star from. First check dead letter table. Okay, so we are getting error reasons as expected. Missing customer ID. If we have unit price invalid, then we are mentioning that invalid price also. Invalid performance score. If it, in this case, it is greater than 400, which is 451, then we are mentioning it like this. Missing order ID. Again, for negative unit price, we are mentioning it as invalid unit price. So far so good. We are getting our as expected values. So here it states missing customer ID. So if we'll check here under customers, we don't have data. That means this missing customer ID is correct. For this performance score is nothing. So if we see here, we are okay, it's something 420, which is 424, which is greater than 100. So that value we can see it here. This means that whatever logic we have written for this part, that is working as expected. Now let's quickly check for our another table, STG orders table. So if we check this, so far so good. We are getting clean data as expected. This means that this silver layer stage 1, whatever we have written, that is working as expected. Now we are going to move to our stage 2 under silver layer. But before this, come back to workspaces, changes. I'll discard this extra file. I have used that to perform some executions, but that is not needed for this project. So I'll just discard it. Now we just need to push this file, okay? Comment, you can say feature. Again, this is up to you what description you would like to have. And then we will push our code. Let's wait. Okay, so this is successful. Going back to our Git, let me refresh it. We have some changes here. We need to compare and pull our request. Again, make sure to change base from main to dev. Create pull request. It is checking for the conflicts. Merge pull request. Confirm merge. Okay, so our feature branch has been merged into dev. Now coming back to our Snowflake, we need to write code for silver stage 2. So for that, I'll create another feature branch. So first switch to dev. Okay, now we will create another branch. So, okay, so by mistake I have given 04 instead of 03, but let it be. Now the next name would be feature 05. So create new feature 05 silver stage 2. We are creating this branch from dev. Click on create. Make sure our new branch has been selected here. Back to files, add new file, SQL file, and give the name as 04 silver stage 2. Now we will start with our stage 2 part where we will perform star schema. Now let's start with our data modeling part. First, we will set our environment. For that, we will use role as sysadmin. Then we will use dev database, which is Flowbridge DevDB. Then we will use schema, silver schema, and warehouse would be pipeline warehouse, which is Flowbridge pipeline WH. Run these statements. Now we need to create sequences. So if you remember, for each of the dim table, we will need surrogate keys, and those surrogate keys will be auto-incremental. For that, we need to create sequences. We will create 5 sequences, one for each dim table. Sorry, we will create six sequences, 5 for dimensional and 1 for fact table. So to create sequence, we need to say create sequence if not exist. We will create these sequences under silver schema. Our first sequence name would be dim customer sk sequence, which will start from 1, and we are going to increment it by 1 digit. Comment is again optional. Let's run this. It has been created successfully. Now I'll just copy this and we'll paste it for 5 times more, and we will just make necessary changes. So dim customer is done. Next one would be dim product. Then for dim supplier. Next would be warehouse. After warehouse, we'll have shipment. And now we would write it for we would create it for packed orders. Let's run remaining sequences. All 5 has been created successfully. Now, next part is to create all dim tables and one packed table. First, we will write our dim customer table. We'll say create or replace table. This would be again our standard table, which is nothing but permanent table. Schema, and then our table name would be dim customer. Now we will write our column names. So first one would be customer SK, which would be our surrogate key with data type number, and we are going to default it to our sequence which we created here. So we'll just copy this sequence name, and each time we will have next value, and this will be auto generated. Then we will have customer ID. Add string, and it should be not null. Then we will have customer name, which would be string, and again this needs to be not null. Customer region, string, not null. Then we are left with customer segment, string, not null. And we will add 3 more column names here, which would be, first column name would be is active with type boolean, and default value for this would be true. So this would be our soft delete flag. If it is false, then that means customer no longer is appearing in orders. Okay. Then created at timestamp would be timestamp ntz, and this would be defaulted to current timestamp. This timestamp would be that timestamp when customer first inserted when that customer value was inserted into this table. Okay. Then updated at, again value would be same as above. This would be when customer value or customer details were updated. Okay. And again here you can mention comment for this complete table. We can say customer dimension for star schema. We have surrogate key via sequence. I think these details are fine. Let's create our dim customer. It has been created successfully. Now let's move ahead and create dim product. Again here product SK would be our surrogate key and product ID would be our business key. Create or replace table. Our table name would be dim product. Again for each of the table, these 3 columns would remain same, and rest of the values we will enter. Okay. So first would be our surrogate key, which would be product SK of type number with default value of this team product sequence, team product SK sequence. So we will write that here. This would be auto generated. Then again we have our business key as product ID, string, we need it not null. Next would be our product name. This would be again string, not null. Then we have category, which would be string, not null. Then we have unit price. Float, not null. So if we check here, these are product ID, product name, category, unit price. Quantity, we will use it into fact table directly. Now we need to mention comment. Here comment would be, we'll just change this to product dimension. Run this query. Okay, so it should be dot next file. This table has been created successfully. Let's verify our objects. Now we can see we have two DIMs here. Now next, create our DIM supplier. Create or replace table. Name would be DIM supplier. Again, these three values would remain same. In comment, we will just say supplier dimension. Now here, we need to add our rest of the columns. So again, first key would be our surrogate key for this, which would be supplier SK. Default this would be supplier next value. Then our business key here is supplier ID, string not null. Then we have supplier name, string not null. Then we have supplier country, string not null. Then we have lead time days, which is number, not null. And lastly, performance score, which would be float, not null. Okay, so here country we have mentioned as supplier country. Then we have lead time days, performance score we mentioned, supplier ID we mentioned, supplier name we mentioned. Okay, so far so good. Create this table. Okay, this needs to be comma. This one is completed. Refresh. we have one more table added here. Now, next is to create dim warehouse. Create or replace table name, then we'll mention last three column names along with comment. Here we'll say warehouse dimension. Now our surrogate key comes here, which would be warehouse sk of type number with default. Here we will use our sequence value. Here our sequence value needs to be warehouse sequence value. Then next, our business key would be warehouse ID, string not null. Then we'll have warehouse location, string not null. Then we'll have, I think we are done. Let's check. Yes. Warehouse ID, warehouse location, and this inventory level, we will use this into fact table. Now we will create our dim shipment. I think we have run this, right? No. Just run this. Okay, table, sixth table is there. Now we need to create dim table for shipment. Create or replace table. Dim shipment. We'll use these three columns as it is. Now here first would be our surrogate key. Let's name it as shipment sk. Would be dim shipment sk sequence. Dot next value. Then business key would be shipment ID. Then we would have carrier. Then we would have ship date, shipment date as timestamp ntz. Then estimated delivery. As date. And I think we are done. Just verify it. Okay, this is where we have shipment. We have shipment, or we have carrier, we have delay days. Okay, so delay days we will use under fact orders, estimated delivery, ship date, and shipment ID. Now let's run this. Refresh. Now we have one more table under silver schema. Now we are done with all 5 dim table creations. Now we need to create our fact orders table. So this one will be our central fact table for one row per order, and this would be our permanent table. It will have foreign keys from all the 5 dimensions, which are their surrogate keys. And for orders table, fact orders table, orders SK would be treated as surrogate key and will have order ID as business key. And these remaining measures, which we haven't used in earlier dim tables, those we will use it here directly. Let's quickly create our fact orders table. Create or replace table fact orders. So let's first write surrogate key and business key for orders table. So it would be order SK number with default value of sequence next value. And then business key for this table would be order ID. This would be not null. Now let's write foreign keys from all the dimensions. For first dimension, foreign key was customer SK. Then we have product SK. Let's do one thing. I'll just paste this for 4 times more. First one was customer, then product, then supplier, then warehouse, then shipment. Now we will write our order fields, okay? And those are order date, then order status, payment status, so we were talking about these values. Where it has gone? Yes, these ones, order date, order status. This one we have already used. And this from financials, payment status, we will take it under fact orders, orders field. Okay, so we have mentioned that here. Then now we will mention all the measures. So first measure was quantity. Then another measure was unit price. Then total amount from financials. Then we have delay days. Then inventory level. This one is from warehouse dimension. Not from dimension, from this warehouse section. So this inventory level, which we didn't use under dimension, that we will utilize under fact orders directly. Now we are left with mentioning our metadata, which is nothing but created at with default current timestamp. Then we will mention updated at with same value. Then we will mention ingested at with timestamp. We are not going to default this value. And again, I think we are done with mentioning all the column names. Just we will mention one comment for this table. We'll say fact table, one row per order. We have 5 dim foreign keys. And measures. I think this is enough. Let's run this. Our table has been created successfully. Now we will create one stream which would be on STG orders, and that will capture only insert and updates. Okay. To create stream, we'll say create or replace stream. Our stream name would be STG orders stream on table. Our table name is STG orders. We will say show initial rows true. Comment if you would like mention. Run this. It has been created. Let's say show streams. Now we can see we have two streams under our silver layer. Now our next part is to create stored procedure where we will actually build our star schema. Okay. So now let's start with that. Now let's start with our stored procedure creation. So for that we will write it as create or replace procedure. Our procedure name would be silver to star. It will return string with SQL language as begin and end. So our complete logic that will fall in between this begin and end. So we will divide our logic into multiple parts for the sake of easy understanding. Part 1 would be to create temp table. We will buffer our stream into this temp table because stream can only be consumed only once. Hence, we will use this temporary table as a snapshot for our all 6 merges, which we will do going forward. Then to create that, we will say create or replace. We need to mention keyword temporary table. And our temporary table name, let's say temp stream data. We'll say as select star from, and here we will mention our stream, which is our STG orders stream. And we need to mention our metadata action to capture our new records. For that, we need to mention metadata $action is equal to insert. So this will create our temporary table. Now our next part would be to create merge or to perform merge into our first dim table, which is dim customer, and it would be our SCD1 merge with absurd. So our merge would look like this. Our target table here would be dim customer under silver schema. Then we are performing select statement on our temporary table which we have just created here. Here we are selecting our respective columns, customer ID, customer name, region, and segment. We are converting all these columns into uppercase. Then we are performing deduping here. So we are with this deduping, we will keep the latest orders data per customer, and this will be treated as source. So our target here is dim customer, and our source is this temporary stream data with deduping. And then we are checking this condition. We are matching our source table with target table based on customer ID. This would be our matching business key. When matched, and then we are going to update it. That means that this is existing customer, and we will just update our records. Okay. So here we will just update our records by by assigning source values to target values. So customer name, region, segment, and then we will mark is active flag as true and updated at that would be your current timestamp at which this transformation is happening. Then when not matched, we need to perform insert because this will be our new customer. In this case, we will perform insert and we will insert customer ID, name, region, and customer segment. In this case, surrogate key, it would be auto-generated by sequence by default. Then this would be our part 2 where we are performing merge into dim customer. Now our next part is to merge into dim product. Now let's write code for this. This would be the logic to merge into dim product. In the same way, we are going to merge into dim product again we are using our temporary table which we have created, and we are going to match our source product ID with target product ID. Similarly, we will fetch product ID, product name, category, and unit price from temporary data. Then here we are again performing deduping to pick our latest value. This is our matching business key. This is the logic to update our record, and this is the logic to insert our record. For the update, we are just appending our new values into target table. Again, we are setting is active flag true and updated at would be our current timestamp. Again, for this insertion, for the new product surrogate key, it would be again auto-generated by the sequence by default. So this is how this logic will function for this part where we will perform merge on dim product. Now our next part would be performing merge on dim supplier. Now let's write the logic for this dim supplier. So this would be the logic for our next merge. Here our target is dim supplier table and our source is this temporary table. We are performing deduping to get the latest record. We are selecting required columns from here. Those are supplier ID, supplier name, supplier country, lead time days, and performance score. So this is our target. This is our source. We are matching this condition on supplier ID of both source ID and target ID, both source and target. This is the logic to perform update. and this is the logic to perform insertion. If we have any value changed, then we are just simply updating that record. If we have this value as new value, then we are inserting that record. And again here, our surrogate key for supplier, it would be auto-generated by sequence. Now, our next part would be our fifth part, where we will perform merge on dim warehouse. So the logic for dim warehouse merge is this one. We are performing merge on our target table, which is dim warehouse, from source table, which is our temporary stream data table, with deduping to get latest record. Here we are just selecting warehouse ID and warehouse location. Both will be in uppercase. Our matching condition would be on business key, which is nothing but our warehouse ID. We are matching source warehouse ID with target warehouse ID. This is the logic for update, and this is the logic for insert. Again here similarly, for the new warehouse, surrogate key would be auto-generated by sequence by default. Again here we are setting is active flag to true, is updated flag to current timestamp. Now our next part 6, that would be to perform merge on dim shipment. Now let's write the logic for this. So logic for this would be this merge, where dim shipment is our target, temporary table is our source. Again we are performing deduping. Here we are mentioning one more condition to skip our unshipped orders. Okay, this condition will check we have properly shipped orders into this table. Again here we are selecting shipment ID, carrier, date and estimated delivery. Here our business key is shipment ID, on which we are checking or we are matching business key. This is the logic for update, and this is the logic for insertion. Again, surrogate key for this dim shipment for any new value, that would be auto-generated by sequence. And again, is active flag, is updated, and we are updating carriers of source into target into this update logic. Now our next logic is for part 7, and our part 7 would be perform merge into fact orders. Now let's write the logic for this. So the logic for this would be this one. Here what we are doing, we are merging into fact orders, and this fact order will be our central table that will link all of our dimensions, and it will enable star schema analytics via surrogate keys. So for this, our fact orders table would be the target table, and it would be one row per order. Then we are selecting our required columns. Here our order ID would be business key. This is the foreign key for dim customer. This one is for dim product. This one is for dim supplier. This one is for dim warehouse. And this one is for dim shipment. -1 would indicate not yet shipped. Okay. We have order date, when order was placed. Then we have current status, whichever it is, pending, shipped, delivered, and another status. Then we have payment status. It would be either paid, pending, or overdue. Then we have measures, order quantity, unit price, total order value, days delayed, then stock level at order time, and then when we have ingested at for the audit purpose, which will indicate when Snowpipe ingested this record. Here again our source table is temporary table, and we will perform inner joins on all the dim tables. Okay. So first inner join will be on dim customer, where we will match business key customer ID. Then we will perform inner join on dim product with business key product ID. Then for dim supplier with business key supplier ID. For dim warehouse, supplier warehouse ID would be business key. Dim shipment ID would be our business key. Again, we are performing deduping here to get the latest record. This is our matching business key. We will match order ID of source and target. When matched, then update. This would be our update logic. When not matched, then this would be our insert logic. Here, if you will see, we have surrogate key for customer, product, supplier, warehouse, shipment. Then we have order date. So whatever columns we have mentioned here, those values we are updating here. Okay. Here we will just say updated at, and we will give current timestamp for that. Again here, in the same way, for the new order, if that gets inserted, then surrogate key for that would be auto-generated by sequence by default. So this is how this logic looks like for merge fact orders. Then once we perform this all merge logic, we will simply clean up our temporary table as it is no longer needed. So we will drop our temporary table, which is temp stream data, and we will return one statement, SP silver to star completed successfully. And this is the end of our stored procedure. Now this is how we have written our complete stored procedure, where we have performed all the merges on 5 dimensions and 1 fact, and we have created our star schema by linking surrogate keys. Okay, so now our function has been created successfully. Now let's move ahead to our next section, which is to create task. We need to create one task to trigger this stored procedure. So our task name is going to be silver to star task, which will orchestrate this stored procedure which we have created every 1 minute. And when we have stream data into it, okay, so that will not keep running our stream for no reason, and it will avoid cost wastage also. So let's say create or replace task. Under silver schema, we will perform this task. Again, we will assign warehouse, which is our flow bridge pipeline warehouse. Schedule would be for every 1 minute. And when we have stream data, so we will mention that condition as when system stream has data, and mention that stream name. In this case, that stream name is STG orders stream. Once this condition gets satisfied, then we will call our stored procedure, which is this one, SP silver to star. Semicolon, and then let's run this task. So our task has been created successfully. Now let's resume our task. For that, we need to say alter task, then task name, resume. Let's check all of our tasks. We have 2 tasks under this silver schema. we can see that this task has been started because we have resumed it. And the first task which we created, that is now suspended because we don't have any data into it. So now I think we have done this resume task. This needs to be here. Now we will perform some verifications, okay? So to check if our stream is working or running, we'll say system, select system, stream has data, and then mention your stream. So our stream was this one, STG order stream. So we have one more option here. If you will click on these three dots, you can say place name in editor, or you can also copy the name. Okay. So if we'll say place name in editor, it will mention that name here. Let's run this stream. Value is true. That means our stream has data present. Now let's check all of our tables. I think this needs to be here. Okay, so I have modified this query a bit. So instead of count star as customer count, I'm just mentioning like this: select dim customer, comma count star. Similarly for product, supplier, and so on. Now let's run this query. Now we can see that for dim customer, we have 6 records: product 6, supplier 5, warehouse 5, shipment 263. And under fact orders, we have 263 records. For shipment, we have 263 records because as of now, for each order, we have unique shipment. Okay. If we'll go through our VS Code, here into expected values, for fact orders, we were expecting equal to or less than equal to or greater than 263 values, which we are getting as expected. Now let's do one thing. Let's check the values for tables. We'll say select star from dim customer. Here we can see that we have 6 customers, as we have discussed in the initial part. For North America, we have 2, Europe we have 2, and Asia Pacific we have 2. So we are getting customers value as expected. Now let's check for dim product. We can see we have 6 products. For electronics, we have 2, mechanical, we have 2 products under mechanical category. For electrical category, we have 2 products. This means that this dim is working as expected. Now let's check our dim supplier. Suppliers, we had 5 suppliers and we are getting supplier names as expected. Now let's check our warehouses. Dim warehouse. We have 5 warehouses. One at Chicago, Dallas, Frankfurt, Singapore, and UK, London. Now let's check for dim shipment. This is how our data looks like for shipment. Now, lastly, we will check for fact orders. This is how our fact orders table look like. We can see customer, surrogate key, product, supplier, warehouse, shipment. We have unique order ID and order surrogate key. So far so good. We are done with our silver layer stage 2 work. Now let's push this code to Git and start with our gold layer. Coming to changes, click on push. We'll say in comment star schema completed. Let's push this code. Going back to our Git. Click on compare and pull. Change base from main to dev. Create pull request. Merge pull request. Confirm merge. Our feature branch has been merged into dev successfully. Now coming back to Snowflake. Switch to files. Okay, so before switching to files, let's change our feature branch. We'll switch to dev branch first. Now we will create one more branch and name for that would be feature 06 gold layer. Let's say feature 06 gold and create new branch. Make sure our new branch needs to be displayed here. Switch back to files. We are going to add new SQL file and name for that would be gold 05 gold. Hit enter and now here we will perform our gold layer work. Now let's start with our gold work. Here we will create 5 dynamic tables as we have discussed earlier. One would be aggregation base, then aggregation order fulfillment, supplier performance, inventory turnover, and shipment delays. Aggregation base, it would be our base layer that will join all of our silver dim tables plus fact table at the lag of 1 minute. Then other tables, these would be downstream tables to this aggregation base table. And the benefit of doing this is that silver layer would be queried only once, okay, for all the KPIs. So for that, first we need to set our environment and we will run this using sysadmin role. So use role sysadmin. Then warehouse for this would be pipeline warehouse. We will use database as dev database. And now schema for this would be gold schema. Run this. We can see our changes reflected here. Now we will create our first dynamic table. Let's move to databases first. And now we will see our changes under this gold schema. Now to create our dynamic table, we need to say create or replace. We need to mention keyword as dynamic and then table. Our table would come under gold schema and table name would be AGG base. Here we need to mention lag, which would be of 1 minute. Warehouse, which we will be using for this would be Lowbridge DevDB. Then comment, we will say this is our base dynamic table. And then here we will mention as select. And now we will select and we will join all of our dim tables here under select statement. Our select query would look like this. Here we are selecting certain columns and we are selecting these columns from fact orders and we are joining these fact orders with rest of the dim tables. Here for dim customer, product, supplier and warehouse, we are using inner join because every order is guaranteed to have customer, product, supplier and warehouse. Okay. Hence here using inner join would be safe so that no rows would be lost. But for the shipment, not every order has shipment. Okay. We have orders with status as pending or processing, which are not shipped yet. Okay. So their shipment SK is -1. That means no matching row with dim shipment. Hence, if we use inner join here, that would drop those unshipped orders. Okay. To avoid that, we are using inner join for this dim shipment. Here, for each of the table, we are using alias. For fact orders, we have F, customer C, product P, supplier SP, warehouse W, and shipment SH. And with these alias, we will use certain columns. From fact orders, we will have ID, order date, status, and payment status. We will have measures, quantity, unit price, total amount, delays, and inventory level. We will have metadata too, which is ingested at customers field. We will take ID, name, region, and segment. For products, we will take product ID, name, category. Suppliers, supplier ID, name, supplier country, lead time days, and performance scores. Warehouse ID, and location. So this is how our aggregation base table look like, which is our dynamic table. Now let's try to run and create this table. It states Flowbridge DevDB does not exist. Okay, so this gives error as Flowbridge DevDB does not exist because I have done silliest mistake here. We need to mention warehouse and I'm giving database name to that. So we need to replace it with correct warehouse, which is pipeline warehouse. Now let's try to run this. Again, we have one error and this one would be we need to mention incorrect surrogate key name. This error is occurring because we need to assign correct permissions to sysadmin. So let's say grant usage and operate on warehouse, pipeline warehouse to role sysadmin. So we will grant this usage and operation on this warehouse. Let's run this. Now try to create dynamic table. It has been created successfully. Let's try to query it. We can see that we have data into this table now. It will say count star. We can see that we have 263 entries present into our aggregation base table. Now we need to move to second part where we will create another dynamic table which would be AGG order fulfillment. and our table would look like this. Here in this select statement, we are grouping our values using customer region and customer segment. That's why we used group by customer region and segment. Select certain values from our base table. And again, this is our dynamic table aggregation order fulfillment with the lag of downstream. Warehouse, we are going to use our Flowbridge warehouse. Here, if you'll come to these count section, so orders count, basically what we are doing, we are pivoting our statuses into columns, okay, into separate columns. So we will have 4 separate columns as delivered orders, pending orders, cancelled orders, and in transit orders. And based on order status, we will count those orders and we will show that count in these columns. Here we are using case statements. This case will return 1 if the condition is met, otherwise it will return null value, okay? If order status is equal to delivered matches, then we will count it as 1. Then for the second one, we will add another, for the second, we will say 1 plus 1, 2. This is how that count will get increased if the status is delivered. For the pending orders, we will use both of these statuses, pending and processing. For the cancelled orders, we have order status as cancelled, and for in transit, we have status as in transit. Then here we are having column named as fulfillment rate percentage. So here we are calculating our fulfillment rate, which would be delivered divided by total orders into 100. So here we are using case statement and we are counting our delivered orders and divide by total orders. Okay, so this is how we are calculating fulfillment rate. That means percentage of orders delivered. We are counting it here. Then we are counting revenue KPIs. For this would be our total revenue for this segment. Then we are counting average order value. After this, we are having payment breakdown. So if the payment status is paid, then that will get counted as paid orders. That means payments collected. If our payment status is pending, that means it will go under awaiting payments. So the column name would be payments pending orders. And similarly for overdue, our column name would be overdue orders. Again here we are using case statement, then one and end. This is how we generate our another dynamic aggregation table. Let's quickly run this table. It has been created successfully. Now let's check entries from this table, okay? Select. If you'll see here, we are grouping it by region and segment, okay? So region, we have 3 regions, we have 6 segments under that. For each region and segment, we are displaying count of total orders, then delivered orders, this logic, okay? Then pending orders, cancelled orders, in transit orders. Then here we are calculating fulfillment rate percentage, which is this logic. Then we are calculating total revenue and average order value from this logic. And then we are calculating our paid orders, pending orders, and overdue orders. So this is this logic about these 3 columns. So this is how our this order fulfillment, aggregation order fulfillment column, not column, table looks like. Now our next dynamic table would be aggregation supplier performance. where we will show KPIs of supplier performance. Again, lag for this would be downstream. So our aggregation supplier performance table will look like this. Create or replace dynamic table, then table name, lag would be downstream, warehouse would be pipeline warehouse, then comment, add select from our base table. Okay. Here again we are grouping it by supplier ID, supplier name, and supplier country. So those three columns we would select here. Then we will see total orders handled by those respective supplier. Okay. For that we will count order ID. Then we will have performance matrix. For this we will have average score across orders, and then we will calculate average lead time in days for that respective order. Okay. Sorry, not for that respective order, by that supplier. Again we are calculating revenue, total revenue, and order value revenue, average of supplier's order value. Then we are having delay matrix. Here we are checking orders delivered on time, and then we are checking order with delays. So this would be our delay matrix. Then we are checking on time rate. It would be in percentage. For that we are checking on time count of on time delivered orders divided by total orders. So this is how we are calculating on time rate. Then we are checking average delay when that order has been delayed. Okay. For that we are checking orders those are delayed, and we are taking average of that, and we are rounding it. So this is how our aggregation supplier performance will look like. So let's run this table. Now query this table. We'll see here for each supplier ID, supplier name, and country. We are having total orders, average performance score, lead time days, total revenue, average order value, on time orders, delayed orders, on time percentage, and average delay days. Okay. So this is how this table will look like. Now we will create another downstream dynamic table, which would be aggregation inventory turnover. This is how our aggregation inventory turnover table will look like. Here, this would be our dynamic table with downstream lag, warehouse, pipeline warehouse, as, and then we are using select statement on this aggregation base table. So this warehouse ID, warehouse location, and category, those would be our group by columns. Hence, we are mentioning those columns here with group by. Now, we are checking our order volume. For that, here we are checking orders processed by that respective warehouse and category. Then we are checking total units orders, total units ordered. Okay. Afterwards, we are checking inventory matrix. For that, we are checking our, with this, we are checking our average stock level. Then we are checking our lowest stock recorded, and this will be needed as stockout risk indicator. So this minimum inventory level, it would indicate our stockout risk indicator. Then we are calculating max inventory level. This would indicate our overstock. Okay, so this is our overstock indicator. That means highest stock it will show. Then we are calculating revenue per warehouse and category. Afterwards, we are checking inventory turnover ratio. This would be this value. If it is higher, that would indicate faster moving inventory. That means it is good. And if it is lower, this means that it will indicate we have our inventory is slowly moving, okay? And that would risk our overstock of product. Hence, this parameter would be useful to check our inventory. And this is how we will be able to create our dynamic table named as aggregation inventory turnover. So let's run this dynamic table. It has been created successfully. We will check this table now. We'll see here we have warehouse ID, location, category, respective total orders, total quantities order, aggregate average inventory level, minimum inventory level, max inventory level, total revenue, and inventory turnover ratio. Then next we need to create aggregation shipment delays dynamic table. Our aggregation shipment delays table would look like this. Same lag would be downstream warehouse we will mention comment, then select from this aggregation base table. And here we are adding where condition also, where we are checking shipment ID is not null. And then we are grouping it by carrier and customer region. So in this section, we are having or we are counting shipment counts. We are doing shipment counts. First count is of all the shipments for this carrier plus region. Then we are checking delivered on schedule shipments. If delay days is equal to 0, that means shipment was on time. If delay is greater than 0, that means our shipment has been delayed. So late shipments which has arrived late and then shipments which has delivered as per schedule, those values we are checking under this shipment count. Then if those values are delivered on time, we are calculating their on time rate. For that, we are dividing our count of on time shipments divided by total count into 100. More or greater or higher the percentage of this on time, that would be better for our supply chain. Then we are checking delay metrics. Here we are first checking average delay across all the shipments, and then we are checking worst delay case. Okay, to check or to avoid our SLA breach, we need to check our worst case delay. For that, we are using this max command. Then we are checking revenue. So this revenue would be revenue handled by that respective carrier. This is how our table looks like. Now let's create this dynamic table. It has been created successfully. Let's check what are the entries in it. If you'll see here, we have carrier, then that respective customer region, what are total shipments, on-time shipments, delayed shipments, on-time rate percent, average delay days, max delay days, and total revenue. So this is how this table will look like. Now we are done with creation of all dynamic tables. Let's say if you want to check all the dynamic tables which you have, then for that, in that, let's say suppose you need to check all the dynamic tables present in that respective schema. Okay, so in our case it would be our gold schema. So for that, what command you will use, you will say show dynamic tables in schema and then mention that schema name and run this command. Now this shows all of our dynamic tables which we have created for this project. And it will give rest of the information too, like if you have used any cluster by, then how many rows are there, role, target lag, refresh mode, and rest of the information it will get shown here. This aggregation base table, we have checked it already. What are their values and how much is the count? Now let's say if you'd like to check dynamic table refresh history, okay? So we have one table named as dynamic table refresh history under information schema. You can query that table too. So to query that table, you can say select, let's say we'll select all, okay? Select star from table, and then you need to mention that table. So we'll say information schema dot, that dynamic table name would be dynamic table refresh history. We can add where condition, where schema name, we will mention schema name is gold SCH. We can use order by too, order by refresh start time in descending. And let's limit it to 10 right now. Any which ways we will have less than 10 values because this is our first run. So this is how our table will look like. You can add database name condition also here. Let's say and database name, and we will give this database name. Now let's run this query again. So we can see all our dynamic table refresh history in this information dynamic table refresh history table, and it will show you and it will give you all the details which are required. Refresh start time, end time, completion rate, statistics also it will give you. What was refresh action, what was trigger. So every information you will get it under this table. Now we are done with our gold layer. We need to move to our serving layer now. But before that, come back to workspaces, changes. Let's push this change to Git. We'll say FEAT dynamic tables created. Let's push this code. It is successful. Now switch back to GitHub. This change we need to pull, okay? Feature gold. Compare and pull request. Change base to dev. Create pull request. Merge pull request and confirm merge. This is completed. Now switch back to Snowflake. Switch this branch to dev. Now we need to create another feature branch, okay? So that would be feature 07 serving. So let's create it. Create new branch from dev branch. It's completed. Switch back to files. We are going to create new file here. Add new SQL file. 06, let's say serving. With our serving layer, first we will set up our environment. For this, we are going to use sysadmin role. Then database would be our dev database. Schema would be serving schema. And then warehouse would be. Now for this purpose, for serving purpose, we will be using our analytics warehouse. Okay. Let's run this. We can see changes here. Now we will create our first view of view order fulfillment. Purpose of creating this view is to govern access to order fulfillment KPIs. And this view will be based on our dynamic table, which is this one, aggregation order fulfillment. And we are going to share this secure view with I think project partners. We had 3 project partners. With them, we are going to share this secure view and along. So let's start with our first view creation. Create or replace. Now to create secure view, we need to mention keyword secure view. Then mention schema and view name. It would be comment. We can mention. Then we will use as and then select query. From select, we will mention certain columns. Let's say first write select star from and then our table name. Now instead of star, we will mention our column names here. So our first column name would be customer region, then customer segment, then total orders, delivered orders, pending orders, cancelled orders, in transit orders. Then we have fulfillment rate percentage, then total revenue, then we have average order value, then paid orders, then payment pending orders, and last would be overdue orders. Now let's create this. Our view has been created successfully. Now we'll go to Snow site under Horizon Catalog, refresh this. So we are now under Silver Schema. Here if you'll see we have one object, views. Under that object we have this view, okay? View order fulfillment. We have description, privileges, columns. We have 13 columns. Data preview, you can see your data from here also. You can change your warehouse from here. If I switch to analytics warehouse, then also I'll be able to see this. Data quality and lineage. So in lineage, you can see this is our serving schema. Under that serving schema, we have this view, which is linked to this order aggregation order fulfillment dynamic table, which is under this devdb. So this is how you can see lineage from here too. So under this serving schema, right? If you'll click on this serving schema, create, you have this option to create view from here also. Create and then view. If you'll see, we have 4 types of views: standard view, materialized view, secure view, and secure materialized view. So if you want to check all these views in depth, then you can search Snowflake official document and they have given all the information about all these views. So this is another way from where you can create view. Okay, in our case it is secure view, and the way which I have shown you, this is simply by using SQL statement. Okay, then we will be creating our next view, which is supplier performance view, which will be based on this gold. Under this gold schema, it will be based on aggregation supplier performance. Now let's quickly create that one. We will say create or replace secure view. Our name would be view supplier performance. Comment if needed, add. Then again, as select from our this dynamic table. Now we will select our columns. Column name would be supplier ID, supplier name, supplier country, total orders, average performance score, then average lead time days, then total revenue. Then we have average order value, then on-time orders, then delayed orders, on-time rate percentage, and lastly, average delay days. Create this view, run this creation of view. Coming back to Snow site, refresh, select new view. Under data preview, you can see your view values, okay, from here under data preview. Under lineage also, it will show you as expected lineage, dynamic table, and then view created by using this dynamic table. Now we will create our third view, which is view at inventory turnover, which will be based on this dynamic table. So let's say create or replace okay secure view. Name for this would be as select from this dynamic table. Now we will select our columns starting from warehouse ID, warehouse location, category, total orders, total quantity ordered, average inventory level, mean inventory level, max inventory level, total revenue, inventory turnover ratio. Now create this view. It is created. Going back to Horizon Catalog under Database Explorer. Now we have our third view and its data preview will look like this. Now Coming back to creation of our another view, which is view shipment delays. It will be created on top of this dynamic table aggregation shipment delays. So let's say create or replace secure view under serving schema with name view shipment delays as select from this dynamic table. And now we will mention our column names here. Those would be carrier, customer region, total shipments, on-time shipments, delayed shipments, on-time rate percentage, average delay days, max delay days, and total revenue. Let's create this view. It is successful. Coming back to Snow site. This is our fourth view, and data preview for this will look like this. Coming back to our SQL query, SQL file. If you want to check all the views, one way we saw it from this Horizon catalog. Another way with SQL query would be show views in schema and then mention schema name and hit run. So this is how you can see all the views created under that schema. To query your view, you can say select start from and you can check for any one of the view. You can check for every view, but that is not necessary because from Horizon catalog we have checked it. This is just for understanding sake. You can query your secure views too using select star from. Okay, so this is how your secure view creation will look like under this serving SQL file. Now we are done with our serving layer. Next layer would be of governance layer. Not governance layer, we will apply certain governance policies for our database. But before this, let's switch to changes and push our recent changes to Git. Click on push. It is successful. Now switch to Git account, refresh. This second push, we will compare and pull. Create pull. Okay, coming back. I didn't change from main to dev. Now we will create pull request. Merge pull request. Confirm merge. It has been merged and closed. Now coming back to our Snowflake, we will switch to dev branch here. Then we will create new feature branch. So click on new. So our branch name would be feature 08. Okay. Click on new. Feature 08 and we will name it as governance. Create this branch. Make sure that new branch has been selected here. Come back to files. We are going to create new file. So add new SQL file 07 and then Our file name would be governance. Now here we will write our logic and we will perform and we will create certain alerts. We will check how we can share our data and we can check how we can create reader account. Okay. This is everything we are covering today. In the next part, tomorrow we will continue building on top of what we have done today. So make sure that you have completed all the steps before moving forward. If you have found this helpful, then please like and subscribe and see you in the next one.